Hi, I'm Kian, and today I want to teach you how to find the area under the curve and above the x-axis of a function. So here we have a function y equals x cubed, and I want to find the area under the curve and above the x-axis of this function on the interval from 0 to 1. So the first thing we do is that we graph the function, just the first quadrant part of this function. And you see that under the curve, we can form some subintervals. And with that subintervals, we can form rectangles. So if we use rectangles as the area under the curve, we know that the area of the rectangle is just width times height. So we should find the width of the subintervals, and then the height of the subintervals, and then the rest we do it later. So first, for finding the width of the subinterval, width is equal to b minus a over n, where b and a come from the parts of the interval. So this is 1 minus 0 over n, which is 1 over n. So this is the width. Now for finding the height, we should multiply k, which is a constant, but we don't know the value, times the width, which is 1 over n, we get k over n. And because it's a cubic function and the degree is 3, we should cube this expression to get the height. Now the next step we should do is that we should multiply these two expressions together and then simplify them. So if we multiply these together, we get k cubed times 1, which is k cubed over n cubed times n, which is n to the power 4. So now the next step is to take the sum of this expression, partial sum, from k equals 1 to n. Because we're working with the variable k, we can take out 1 over n to the power 4 outside of the sum. So we get 1 over n to the power 4 times the sum from k equals 1 to n of k cubed. Now the sum of k cubed has a principal value, which is n squared times n plus 1 squared all over 4. Now, if we multiply these together, we see that the value would be n plus 1 squared over 4n squared if we simplify them, because this is n squared times n plus 1 squared over 4n to the power 4, and then the degrees can cancel out, and the final result is n plus 1 squared over 4n squared. So now next thing we should do is that we should simplify this expression. So if we do that, expand the numerator, we get n squared plus 2n plus 1 all over 4n squared. Now the last step is to take the limit as n approaches infinity of n squared plus 2n plus 1 over 4n squared. As always, when taking the limit at infinity, we should divide the numerator and denominator by the highest degree, which is n squared. And if we do that, let me write it. N squared divided by n squared is 1 plus 2n divided by n squared is 2 over n. If we take the limit individually, we see that it converges to 0, so we can replace 0, which doesn't have an impact. And also 1 over n squared also converges to 0. Over 4n squared divided by n squared is 4, so the final result is 1/4. And to make sure you're absolutely correct, you can take the easy way is to take the integral, definite integral from 0 to 1 of x cubed dx. This is equal to 1/4 of x to the power 4. If we put 1, we get 1/4. If we put 0, we get 0. 1/4 minus 0 is 1/4, and we are done. Thanks for watching.